Good afternoon. How's everyone doing? This is a good-looking crowd, man. We've got lots of people here. This is great. We're going to give a talk here on the Node.js Postmortem Working Group, give you guys an update. I'm Yunong from Netflix, and this is Michael from IBM. About me, Netflix, you guys probably already know who we are. We're really interested in this stuff, and we'll get into that, some of that later. But if you don't have Netflix already, maybe try it out.
I'm Michael Dawson. I'm the technical lead for the team within IBM that builds and manages Node for consumption in our products, as well as delivery to our customers through things like our Bluemix paths. And our development our development approach is really very much in the community. We plan to develop out in the community and then pull those improvements back in for our internal use, which means we're very active in the work groups. I'm a collaborator and CTC member, as well as being involved in the LTS build, Postmortem Working Group, and so forth, which is why I'm here talking with you about postmortem debugging.
Which one do you want me to use? Just this one? Just this mic? Okay, so what do you stick with this?
Sure. All right. The other thing we want to point out is that we're just the two people who have the privilege to talk to you about what's going on in the Postmortem Work Group. There's a lot of other people who are active participants. In particular, there's a couple people, Julian and David from Joint, who did a lot of the foundational work that we're building on in terms of the postmortem debugging. We have a few people from IBM, like Howard and Richard, who are active on some of the things like Node Report that we're going to talk to you about today. So before we go farther, I just wanted to make sure that there's a good team of people already working on this. If you're interested, though, we could always use more people and more involvement. So come out and get involved if you have any interest at all.
So let's quickly talk about the mission statement, right? Most of you are probably wondering, what is the Postmortem Working Group? And it's really dedicated to the support and improvement of postmortem debugging for Node.js. And the thing that I want you guys to focus on here is debugging. And that's really, really important for us and for a lot of folks, I'm sure, in this room. Does anyone debugging Node.js? Anyone use some of these tools, right? I'm sure we've all used integrated debuggers in our IDEs. We've used, a few of us probably have used the Node Debug command line tool, and like myself, I mainly use console.logs because I'm too lazy to set things up. But this is sort of the set of debugging tools in the debugging landscape today in Node, and there's a common theme here, which is that you can only usually run these debugging tools in your test environment, and why is that? Why is that, right? Let me tell you about why in an example. So, and the reason that you can't use this in production is we'll get into that. So, for example, so anyone know what this is? Yeah, that's right. It used to be a planet, but it's probably pretty sad now. It still loves you, right? And Pluto, as you know, there was a probe that was sent to it called the New Horizons probe. And I think of the probe as production, right? I'm sending a probe to Pluto, and it's got this very short amount of time to go fly past Pluto and take images and take pictures. And so, suppose the probe crashes or it's got a bug. Do you want to attach a debugger and pause the probe and debug it while it's flying past Pluto? Of course not, right? You want to be able to capture all the data really quickly, and you don't want to miss the once-in-a-lifetime opportunity you're flying past Pluto. And sort of in production, we have the same constraints. And it turns out that NASA, in all its wisdom, back in the 70s actually, they released a paper detailing a methodology called a core dump, right? And what they did with spacecraft is they would take a core dump whenever something failed on the spacecraft, and then immediately restart it. So because their sort of goal here is to minimally impact data acquisition, right? You're flying past Pluto, you only do it once. So there's a problem with the spacecraft or the software. You want to debug it so that it doesn't happen again, but you can't afford to do it then. So what you do is you take a core dump and then look at it later. And that's sort of, let me give you a brief history on the core dump, but that's kind of what postmortem debugging is all about. So back in the day, memory was actually stored on magnetic core memory. So here's a picture of it, and every single little pin is a bit, right? And what programmers and engineers used to do back in the day, before they had the fancy debuggers, is they would dump out the contents of the memory and then inspect it. And so that's why they call it a core dump, right? It's the contents of a core memory. And this stuff was initially printed on paper, and the term postmortem debugging was really born at that time. So what that really means for postmortem debugging is, hey, I take a snapshot of my process, restart it, and then I can look at that postmortem debugging later. And that's really helpful for production, right? Because there's some production constraints, as I'm sure most of you know, and sort of the example with NASA is uptime is critical, right? For Netflix, for many of you out there who are running your own real-time services, you have customers that's directly impacted by downtime. So if you have a bug in production, you want to make sure that you resume service as soon as possible. At the same time, you want to capture that state so that you can debug it later, so you're not hitting that production problem again. For us at Netflix, it's very hard for us to easily reproduce a bug, right? Given the tens of millions of subscribers we have and the different A/B tests and just the different environments, that's really, really hard for us to do that. And again, like I said, the critical thing for us is, if we're down, people aren't like, oh, let's give them some time to figure out what the problem is. They're mad because they can't watch their favorite TV shows. And that's for us, we really want to resume normal operations so you can continue to binge on the shows, right? And so the postmortem debugging methodology really is, you take a core dump, which captures a snapshot of the process, and then immediately you can restart the app and then continue to serve your traffic. So you're not really impacting production at all. And the beauty of postmortem debugging then is you can take this core dump and you can load it elsewhere. Load it off on a box that's not in production and really take your time and really dig in and root cause what that issue is and fix it, right? Because the whole point here is you want to make sure that you're debugging your problems that you see and not just restarting the services and forgetting about them, because if you're not debugging them and fixing them, they're going to hit you again, right? And so for us, customer availability, service availability is really important. So we want to drive down the root cause for most of our errors. And so in Node, you can do the same thing here, actually. So you can enable Node to dump a core when it starts. So you can say a Node with the abort on uncaught exception flag. And anytime you throw an error that's uncaught in Node, as you know, normally when you throw an error that's uncaught, it immediately exits with a stack trace. In this case, if you enable that flag, you'll see on the bottom here that the operating system and the Node runtime will actually dump the core contents of the memory onto a core file for you and save all of that state. And this is really helpful because in addition to a stack trace where it tells you, where my app crashed, it's helpful with a core dump because it shows you why it crashed. You can inspect the heap and stack variable state as well. So even though you have a stack trace, you may not know the arguments or the variables or the state of all the variables on the heap. With a core dump, you can look at that. And this working group is really around providing the tools for you to be able to inspect all of that information. In addition to just capturing a core dump when your process exits, sometimes it's also really nice to be able to take a core dump of your process while it's running, even though things aren't failing immediately. And you can do that on most Unix-like operating systems by running gcore, followed by the PID of the process. And this will actually take a core dump of your process while it's running. And this briefly pauses the process, but it's really fast. So it's a really good, easy way for you to capture a core dump of a process you think may have gone awry and then look at it elsewhere as well. So it's best to illustrate sort of the advantages of postmortem debugging with an example. So I gave a talk earlier today about our new API, Netflix API architecture. If you guys are interested, you should check out the video of that later. But for all of our clients, when they come in, our new architecture, they hit a node-based process where they've written their APIs, and then that service then forwards on the request to the Edge API, which then forwards on to the backend services. But in Node, we have a connection pool that helps us do client-side load balancing to the Edge service. So you can think of this like in Node, I have a connection pool, I have a bunch of connections, and those randomly will pick some subset of API instances that's available out in the world. And what we were seeing when we were testing this new stack is that the Node services were consistently saying that there were no free connections in the pool, which is really weird. And how would you actually debug this if you think about it, right? Because I don't have context or logging that tells me right now what's in the pool. And when I go look at all the available instances that's out there in the API service, they're all up. So there's some bug in Node somewhere in our Node client load balancer where we're not making those connections. And I don't actually know the internal state of my program, right? And so the other thing that was hard about this is that when we restarted the service, the problem went away. So I bounce the service, it goes away, and then at some point in time, on some small number of these instances, the problem comes back. So I could go add logging statements, but I'd have to wait for everything to reproduce, and maybe I didn't add the right logging statement, so hours later, after this iteration would take forever. And so what we did instead was, again, use this postmortem debugging technique. So we take a core dump, and then we start the app, and immediately then we have a fully baked, a load balancer with full connection, so we're continuing to serve traffic. And then we took this core dump and we loaded it on our debugging machine to try to figure out why the load balancer wasn't working. And here we're using a tool called MDB V8, which is a tool that's produced by the Postmortem Workgroup. But one of the commands that we're using is showing, hey, find me the JS object that contains all of my connections for the connection pool. And here we could easily see, and this is the actual JavaScript object, we could see that, hey, we have a bunch of free connections, but none of them were connected. So like this instantaneously pinpointed to us, what that bug was, which is like, hey, in this block of code where we're freeing connections, we weren't, there was a bug where we're not putting them back into the connected pool. And so this was a really good example of like how postmortem debugging can really help you solve these really nuanced, sometimes subtle bugs in your code that you can't reproduce easily and it's in production. And so, I want you guys, the one takeaway from this section is that for us at Netflix and for a lot of companies, postmortem debugging is actually really, really critical, especially in large-scale production deployments, because there are a lot of problems that we encounter in production that you can't solve, or it'd be really, really hard, or really, really time intensive to solving any other way. And so without this tool set, for us, that business decision of using Node becomes a lot more difficult. And so this tooling is incredibly important. And with that, I'm going to hand it off to Michael, who's going to talk a lot more in detail about the working group.
Okay, thanks. Yeah, thanks. Yunong gave us a really good example of why we should be interested and why this is important. I'm now going to delve in a little bit more into the current state and what the working group is doing to improve that. So the overall mission of the work group is to basically guide the improvements in the postmortem story. That includes defining things like interfaces and APIs. We want to make it easy for people to build new tools without having to reinvent the wheel. So some good APIs and interfaces that lets us introspect the artifacts we can get out for postmortem debugging. Similarly, things like dump formats, we want to define and standardize those again so that you can build and leverage on top of them. And then also build up a set of tools and techniques that helps people coming who are newer to the concept to get involved and get ramped up quickly in terms of getting their debugging going. So taking a little bit about look at the state of the tools today, there's really two key artifacts that people use for postmortem debugging. The first is a heap dump, which is a snapshot of your heap. In managed runtimes, of which Node is one of them, the memory that you use within your application is largely contained within that heap, and a lot of information you can really get out by looking at the heap contents. Today, traditionally, that's done, the heap dump module, which is an NPM module available and made by Ben Norhaus, is one that's most commonly used. You can actually take the heap dumps that it generates and open them in Chrome Developer Tools, and then, compare between, say, two heap dumps to see if you're leaking memory or try and figure out, some information about the objects. There are, however, a number of limitations in terms of using the tool, not necessarily related to the implementation of the NPM itself, just due to the fact that, heap dumps have a lot of data relationships, and so the generation of them can be quite long when you have a large heap. The second thing that's often used is core dumps. So instead of just being, an image of your heap, these are a complete memory image of the process that was running at the time. And as Yunong mentioned, these can be generated a bunch of different ways. Like when you crash, operating systems will often give you one automatically. You can add the abort on uncut exception to be able to generate it when you have an uncut exception. And you can also, use tools like gcore to generate them. Advantages is it's fast to create these relative to heap dumps. They can still be fairly large though if you have a large process size. The first way you can start to go and look at those artifacts, the core dump artifact, is to just open them up in the debuggers. Unfortunately, that can be a lot of work because they don't have any knowledge of the structures of V8 and Node. So if you want to actually look at an object, you have to know that, okay, the map that has the fields is 4 bytes into the object, and then decode all that. And so you can look at it with those tools, but that's a lot of work. So to get over that hurdle, a number of tools have been developed. So these are basically core dump inspectors that know about V8 and Node structures. There's several out there today. Yunong mentioned MDB, which was one of the earlier ones. IDDE is another one made by IBM. And LL Node is a newer one that is being worked on within the work group. If we take a quick look at the, some of the commands between these different ones, it'll give you a flavor of what you can do with them. You can print a stack trace for the executing thread. You can find objects. You can print the contents of an object. Find constructors, all sorts of really useful information. Today, unfortunately, the story is a little bit fractured. If you look at the different tools, they have different commands. They'll have a different subset of commands, and that's one of the areas we're working to try and bring everything together to make it easier and more consistent to use across platforms. So for example, MDB has a certain set of features, but only runs on a subset of platforms. And then, LL Node will work on a different set, and so we're trying to make that more generic. So looking at the current state, how do we actually make that better? For one, we want to improve ease of use, so that involves better platform support, more consistency. We want to provide more APIs so that if you don't want to use the inspectors that are there yourself in the existing commands, you can write your own more easily. We want to make sure you can ensure platform support, so across all the operating systems and architectures. Common command sets, you only have to learn things once. And then a little bit different from, we've been talking about core dumps, but often, if you have a problem, you don't need all of the information in the core dump. So is there some smaller subset that we can get even faster and even easier and actually look at even with less tooling that will help us get going really fast? And that's what we're calling the lightweight dump. So specifically, the working group is working in a bunch of key areas now, and the overall goal is what we've outlined. But the first one is the common heap dump format. So that's a common format for the heap dump, which we can then let tools interpret. The other difference also from what we do today is to be able to generate that from a core file. So instead of having to go through at failure time, the long process of generating the heap dump, be able to quickly generate the core dump and then get a heap dump out of that. As I mentioned before, improving core dump analysis. So taking the tools, making sure they're cross-platform and more consistent. And then building libraries both in C and JavaScript being key because we're a JavaScript community, and the more people who can write these extensions, the better. And then finally, Node report, which is a lightweight dump. The common heap dump format, the key thing we see there is it's a real enabler for new tools. If we have this format and you can use APIs or read the format itself, then that's a way we can sort of accelerate the path to having lots of good tools for doing postmortem debuggers. Today, our thoughts for generation is that you could actually generate it, as I mentioned, from a core dump. So in MDB or LL Node, you could say, let's take this core dump and generate the heap dump. And if you want to learn more, you can go to the issue number 19 in the Postmortem repo and read up what's going on that front. In terms of consuming those heap dumps, we're all familiar with the tools, the Google tools. So probably something that's going to convert that format into the existing format so that we can still open them up in Chrome Developer Tools is going to be useful. And then also the C JavaScript tools. So basically whatever new tools people can imagine can read off that core dump as well. In terms of core dump analysis, really the focus is getting better platform coverage, reusing the existing command implementation. So MDB has a good set of implementation for those commands. We'd like to bring that logic and code, if we can, to some other platforms like LL Node, which has perhaps a little broader platform support. And then building common APIs that you can interact on top of stuff like that. So if you're interested in those things, you can go out to the repo and look at issue 37 for discussion on the Common C library, as well as LL Node, which is a project at Dewtney started, but will soon be moved under Node.js as part of the working group's efforts. The goal we're trying to get to is basically to this, a picture where you have this functionality. You've got your core dump generated. You now have, one or more debuggers, so MDB, LL Node, DBX, which is an AIX platform support debugger. They'll have core dump readers that know how to understand core dumps, possibly from different languages, so different operating systems, so you don't even necessarily have to debug your core dump on the same platform that it was generated. Then on top of that, the debuggers will provide a set of APIs, so a C API. Built on top of that will be the JavaScript API, and you can, then build web-type apps directly on top of that API without having to drop down into like C code, for example. Hopefully making that a lot easier for people to write interesting NPM modules and other applications. The last thing I'll mention that we're working on is, second last is Node report. And basically, the idea here is that we want to get a lightweight dump, which is fast, very fast to generate. It's small, it's human readable, and it's got the key information that you need to start investigating. There's lots of issues I've run into where if you just had, say, the environment variables that were set when you ran, was my U limit 0, or what was my heap setting? That just by looking at that, you could basically figure out what was going on. And so it's to give you that kind of information. Being able to be generated off things like exceptions, fatal errors, signals, or even say have the JavaScript API say, hey, I want to generate a node report. This is a quick example. It's a bit hard to read, but basically, you know, there's already work on this. You can go to the repo Node.js node report and take a look at the code that's there, but it gives you, you know, just the key information you need about things like the events that are going on, your OS and node versions, stack trace of the current executing thread, heap and GC statistics, resource usage, OS ulimit settings, all that kind of stuff that I think you'll find really, you know, in a lot of cases will let you solve the problem without it even having to delve even deeper. In terms of the JavaScript API, you know, the goal here is to make things more accessible. Today, a lot of work, if you want to do or extend the tools in Postmortem, you have to actually do that in C and C++ code, which is a bit of a barrier to entry and speed of development for a lot of people in the community. So what we want is a JavaScript API that can either work off that common heap dump format or perhaps directly off of a core file. In the case of, you know, LL Node is in our proof of concept work, the JavaScript API just drives and introspects the core dump using the LL Node debugger. If you want to read more about that, again, you can go to issue 33 in the repo. And, you know, here's just a sample application that we wrote that, you know, given a core file through JavaScript in a simple Express application, it can go out and show you the stack trace for your application. So you wouldn't even necessarily have to copy that core file off your machine. You could simply have a little application which lets you introspect it where it is. So in summary, you know, I've told you a bit more about, you know, we've told you what postmortem debugging is. Yunong had a very good example of where it's helpful, and we gave you a little bit of an overview of, you know, the activities of the work group, the common heap dump format, the APIs we're working on, and some of the tools, you know, LLDB, MDB, and Node report. Before I hand it back to Yunong, I just want to say, get involved. I think this is it's a really good chance to learn. You know, you can learn low-level machine details, key debugging techniques, different platform and operating systems. So if you want to learn any of those things, this is a great place to get involved to do that. Most of the work is done through GitHub, so you can go to you know, Node.js Postmortem if you want to get involved, and so I look forward to seeing some of you guys there. I'll hand it back to you.
And like what I was saying earlier, this is really critical for a lot of folks and for us as well. So we want to see, you know, the community, which is you guys, and the foundation and folks working on it, really invest in this debugging tooling. You know, for a really mature runtime that, and for ecosystems that we want to see more uptake and more adoption, especially in production. This is sort of critical tooling that you need to get this, to be able to run your services reliably. And like the takeaway here is with postmortem debugging is there are going to be cases where some production problems are just otherwise impossible to debug. And so the only way for you to do that is by using the postmortem tools where you can save that complete process state and debug it later. And that's all we had. Yep. Thank you very much.
We have a couple minutes if anybody has any questions.
So that already actually, that's a great question. That already exists today. So if you fire up, you know, MDB or LL Node with a core dump, and you print the stack trace, it will actually show you everything from system calls to so it will show you everything from libc to the V8, the native V8 stacks, to the JavaScript stacks, and all the way up to stuffing userland. So you can already do that today. And then if you're using other techniques where you can sample the stack traces, this is a little bit not relevant to the postmortem case. You should be able to see everything. So with dtrace or perf events, you'll be able to sample stack traces and see everything all the way down to system calls. So all that stuff already exists today. Yeah. So, I mean, I don't have my laptop. I could show. It's those stack frames for native debuggers like MDB or LN or GDB, right? They don't understand the JavaScript stacks because they don't know the format, and this is where this common C API and the JavaScript API comes in handy because it understands the format of both, you know, variables on the heap and stack frames. So it's able to take that stack frame or the set of stack frames that's in JavaScript, interpret them, and then print them out in line. So if you actually go fire up, you know, grab MDB V8 or LL Node, and you just print out the stack trace on a core dump, you'll be able to see native stack traces and JavaScript stack trace all in line in one, exactly as you would expect, actually. So all that stuff already exists.
And this doesn't require like a special build as well?
No. This is all. Oh, the thing that I forgot to mention is where this is really powerful is we're not running some special distribution or anything like that. We're just running a vanilla copy of Node that we install from Node.js.org.
Yeah, that works because there is additional data added into the community Node builds to be able to make that happen.
Saw a question back there. Yellow shirt? Yep.
So it's great that you can dump the state, but some kind of problems, they depend on what the code did in the past history.
Yeah.
And as far as I know, the only way to debug that is by having logging statements. So you need to have them beforehand. But the problem is in large-scale deployments, if you do logging, then that will generate a lot of data, and searching through logs can be very cumbersome. You guys have some ideas about how to address that? Is that in your goal at all?
So it's not in the. This is a good question. It's not in the goal of this post-mortem working group, though we probably should incorporate that. Actually, Microsoft's done some really great work with time travel debugging on their Chakra core, which is a competitive VA, and that lets you actually record state of the entire running process through time, and it keeps that state in a ring buffer, so it'll keep the last number of seconds or minutes or whatever, and then you can actually literally go back and forth through time and look at all of the states. So that's a really great point.
I'll just add that the line's a bit fuzzy. There's also a diagnostic work group. And in that work group, there's definite work going on in terms of tracing and adding in better features to make tracing lighter weight, easier to turn on and stuff like that. So I'd go look there if you want to look at that in a little bit more detail. It was a diagnostics work group. So if you go to like Node.js/diagnostics, there's probably some issues talking about exactly that.
Yeah. But if you're interested in time travel debugging, definitely, I don't know that anything exists for V8, but you should file an issue and that'll help drive the community to get that stuff set up. Thank you.
Thanks.